Hello all, thank you for coming to our capstone demonstration video. Our project this year was to develop and implement a wireless network of gas sensors to detect and localize the position of a gas source. And what you're seeing in front of you is the GUI we developed to monitor the efficacy of our localization algorithms. The COM algorithm being developed by Trey et al. In 2016, and the TDCOM algorithm being the localization algorithm developed by us, Team 8. So to give you an idea of how our system will work, we will be using the generate data feature. And what this basically does is simulate a point source at a known position. And then our system, using the fixed sensor positions, will acquire data and process them using the COM and TDCOM algorithms respectively and try to estimate the position of the source. So let's set the source position to something, let's say close to sensor 2. So about 0.9 meters X and 0.2 meters Y. And let's start generating data. So once the threshold is exceeded by one of the sensors, this green circle will turn red, and it just did, indicating the presence of a gas leak. Now, the red dot represents the source position estimate using the COM algorithm, while the blue dot represents the source estimate using the TDCOM algorithm, and they are continually updated as measurements are taken in. As you can see, the TDCOM algorithm estimates the source position that is much closer to the actual source position than the COM algorithm. However, this is using simulated data, so let's go to the test chamber and run some experiments and see if this actually holds. So our new test apparatus will consist of this queen-size bed frame that will be used as our enclosure. As you can see, the sensors are mounted on the inner wall. This bed frame is 2.5 meters by 1.5 meters, and it has a much less Z height than the full room does, which will minimize diffusion of CO2 in the Z direction. On the X's on the floor were the positions where we placed our point sources and made measurements. Before running tests, we covered this whole bed frame with a tarp to prevent CO2 from diffusing out of the frame. So the sensors send data to a Raspberry Pi, which is mounted to the touch screen. More specifically, our sensors actually send data to this Arduino, which communicates to a Raspberry Pi through a serial interface, and then the Raspberry Pi processes the data and will produce source estimates. We will monitor the activity on this GUI that we developed, and it will be testing both the TDCOM and the COM algorithm's efficacy in determining the point source's location. So, this is a glass of vinegar, and inside is a folded Bounty napkin, which is absorbing vinegar as it's being soaked in there. In this glass is some baking soda. To create a diffusing point source, I simply just take this vinegar-soaked napkin, put it in this glass, put it in the position that we are interested in localizing. And the vinegar will slowly move from the napkin into the baking soda, react at a fairly constant rate, and diffuse out of the cup like a diffusing point source.
So here you can see that the TDCOM method outperformed the COM method by quite a bit. We performed a total of 4 test runs, and in 3 of the 4 test runs, the TDCOM algorithm beat out the COM algorithm. And in the one test run that didn't beat the COM algorithm, the TDCOM method was just slightly worse than the COM method.